Hello everyone and welcome to another video for Elephants VFX Patreon. In this short video, I just want to give you an overview of this tool for Houdini Solaris that I found online that I think is pretty cool. It solves, or it tries to solve at least some of the issues that we usually deal with in production, especially when lighting interior shots. And I think it's still in early stages, and sometimes it crashes, sometimes it works great. But anyhow, I just want to show you quickly how to use it. But most importantly, I want to give credit to the person that created this tool. So you can go to the GitHub, download it, and just test it for yourself. And send feedback to the guy, or just if you feel like this tool is good and is useful for you, please just send him an email or a Twitter message or something, just saying that you like the tool, because the guy is putting a lot of effort on making this tool available for everyone. It is free, and I've been testing it for a couple of days, and it seems to work okay. So yeah, I just want to give you a quick overview of how to use this tool. To give you a little bit of context, well, first of all, this is the GitHub, right? GitHub.com. This is the username, and the tool is called Lighter. So yeah, again, to give you a little bit of context, this tool basically takes an HDR image and extracts all the practical lighting source. Well, they don't need to be practical, but any different lighting source that you can find in the HDR image, it can be extracted to be manipulated individually. Again, either if it's a practical light, like a lamp or any other practical light, or let's say a window or a hole in any wall or whatever it might be, right? But anything that throws light into the image that belongs to that HDRI, it can be extracted and manipulated individually. And this is a very common problem that we have in visual effects. Well, actually, it is not a problem. It's just a technique that we usually do in visual effects. So when you are lighting a shot, and let me show you here, maybe to explain this a little bit better, I'm going to jump directly into Houdini, because this is just a quick practical demo. And again, I'm not involved with this tool at all, so all the credit goes to the person behind this tool, of course. I just want to show you quickly how to use it and what I think is a great tool, or potentially could be a great tool for your toolset. So quickly, let me just go here to, I just want to create a cop network very quickly here. Let me create a file image, and I'm just going to take one HDRI that I have here that I downloaded from Polyhaven. So let me set this viewer to composite viewer. Okay. Come on. All right. So here I have this HDRI. So when we're lighting, in visual effects lighting, when we're lighting a shot, well, there are many ways of lighting a shot, of course. If we are working with real context, meaning that we shot an HDRI on set of a location where we're planning to do some kind of visual effects work, again, the starting point, it is usually an HDRI. When lighting shots with HDRIs, there are usually a couple of different situations. Generally speaking, one, it would be exterior lighting, and another one would be interior lighting. And those can be treated in a completely different way. Interior shots, they are a little bit more complex in the sense that we usually have more lighting sources. Again, those can be windows, those can be practical lights, those can be anything that throws light into the shot. When working with exterior shots, it's a little bit easier because generally speaking, we're going to have two different lighting sources. One, it would be the sun, and the other one, it would be the sky. Again, it could be different variants here, right? We can also have practical lights outside. We can have different cheats that we do on set, like black cardboards to create negative space, or white cardboards to throw bouncing light. We can do different kind of cheats and treats, and this is part of cinematography in general. But again, generally speaking, it will be just the sun and the light. And these days, if the only lighting sources that we care about is the sky and the light, again, these days it's very easy to deal with that situation. We just have an HDRI image of that location. We connect that image to a skydome or any kind of environment light. The naming changes depending on the render engine that you use. And, the path tracer takes care of the rest. That's generally speaking. Then, there are variants that we can talk about in a different video. But again, if we minimize everything to the basics, basically, we end up with just one HDRI that is calibrated, that has been balanced properly, and we connect that to a skydome, and it works perfectly fine. A few years ago, before path tracers were kind of like the standard for rendering, we used to divide those HDRIs of exterior locations in three different maps. So we would create a light rig that contain, again, generally speaking, okay, three different lighting sources. One would be the North Pole, or just the top of the HDRI, meaning the sky. Then the south, meaning like the bottom half of the image, and this was mostly for bouncing lighting coming from the ground. And then you would have the main direct lighting source, which would be the sun. We don't do this these days anymore. There are some situations where you might still want to do that, but generally speaking, we don't do that. But when it comes to interior lighting using HDRIs, it's a little bit different, because calibrating the HDRI perfectly is a little bit tricky when you have multiple lighting sources, especially if those lighting sources or practical lights have different color temperature. It is possible to do it in one single HDRI, but generally speaking, it is better to extract all the practical lights into multiple HDRIs that you can map into CG lights. So for example, in this image that I have here, we could probably divide this into 4 different lights, right? We could have an environment light, and then we could have 4 CG lights, one for each of these practical lights that we have here in this studio, and then we could control those individually. So this will give us, there are 2 benefits of doing this, or maybe not 2, but 3. The first one is that we would have to spend less time in Nuke calibrating the HDRI. Because let's imagine that we only use this HDRI as lighting source. Well, we take this into the 3D software and the render engine, we hit render, and we realize that this specific light doesn't have enough intensity in the render. Well, then we need to go back to Nuke, we need to tweak that light, export another version of the HDRI, test again in the 3D render, and maybe it's fine. Or maybe we realize like this other light, the white balance is a little bit off, so we need to go back to Nuke, and So basically, we would save time if we can control those individually directly in the 3D software. Another benefit is that we have more creative control. And again, if we want to change something in the HDRI, let's say that the global exposure of the image is maybe too low, it's underexposed. Well, if we increase the overall exposure of the HDRI light, the sky dome that we're using in the 3D software, we are affecting all the lights at the same time. We're affecting all these practical lights and also the environment map at the same time. So, we don't have a lot of margin to work with. We don't have a lot of options to play when it comes to creative control. And the third benefit of splitting this into multiple lights, it would be technical reasons, right? For example, sampling. Let's imagine that instead of these 4 lights here, we only have one, which is very small in the middle, and then the environment light. Well, we would have to sample these a lot in order to get noise-free renders, right? And there is what is the point of sampling a big 4K or 8K map if we only care about, 128 pixels here that we want to sample? So it would be beneficial for us to get rid of this light in the HDRI so we can have less samples in this whole big area. And then we can focus sampling in just this small area if we map this into a CG light. So those are, I would say, the 3 main benefits. It might be others. We might have others, but those are the main 3 that I can think about right now. Of course, there are some disadvantages as well. For example, in order to share that light rig with other members of your team is a little bit more complex, right? If everything is embedded into one single image, it is much easier to share that with other team members. If you need to split this into 5 different lights, then there are more information that you need to move through the pipeline, and there could be mistakes and whatnot. And of course, sharing that lighting setup with another vendor in case you're working on a show with multiple vendors and multiple vendors need to reuse assets, it's also a little bit more tricky. So there are pros and cons as everything we do in visual effects. Okay, so that is kind of like the context of why we want to split interior HDRI images into multiple lighting sources. Traditionally speaking, this is something we do in Nuke. Nuke is great at working with high dynamic range information. So extracting all this information in Nuke, it's a very common technique. We do this all the time. I worked at some visual effects facilities where we used to have internal tools to deal with this. And as far as I can remember, I'm trying to think here, but as far as I can remember, all those tools were built inside of Nuke. I don't remember having these tools available in a 3D software. I think everything was created in Nuke and published through Nuke, and then it was easy to use it in whatever 3D software we were using at the time. I would assume Maya or Katana. But this tool, again, takes care of all of these in Houdini. And, it has some bugs here and there, and it's not super fast, but generally speaking, it works very well. So I just want to show you quickly how to use it. So I'm going to go back to Houdini, and let me go to stage. So basically, we're working with Solaris here. And as usual, I'm working with ACES, and I'm displaying this as Rec 709. Okay, that's great. So I just prepared a tiny scene here. So let me create a sublayer node. And in here, if I go to jobs, USD, I have this thing called scene version 1.usd. And it's basically this tiny thing. Okay, so there is not much here. I have a published camera, and this is what the camera is looking at. And if you check my scene graph here, this is the structure of my scene. So basically I have my sequence 01, my shot 01, and then I have my render camera, my geometry, which it's basically a backdrop, a chrome sphere, football, a gray sphere, and a table. And then I have a context for lights, and then I have another context for materials, and these are the materials that I publish for all my assets. As simple as that. Okay, cool. One thing that I'm going to do actually is I'm going to get rid of my backdrop because that looks nice in the final render, but you know, while you are look debbing these things, or I mean, they are already look debbed, but while you're testing the light, of course, it will take some time to clean up the noise in the background because there is a lot of bouncing light over there. So basically, I'm going to get rid of that. So I'm going to create a prune, and I'm going to take my backdrop so I can get rid of that. Okay, cool. And now I'm going to add a layer break because this is where my lighting starts. Okay, so if we take a look at there, this is what we have. Again, all of these have shaders and everything already, so we don't need to worry about anything. This is a published USD file. So we just want to work on the lighting now using this tool. By the way, this tool is called Lighter. You need to install it. And in order to install it, you need to download this GitHub repository. So just download that zip and zip it anywhere you want. In my case, I just place it here inside of Lighter, utils, and this is the zip file that I downloaded. And I unzip it here, Lighter main. This is how it's called. I haven't changed anything. So it's basically here. So you need to point to these in your environment variables. So basically, if you just go to your Houdini emp file, you can see that I'm pointing to that. So Houdini path equals to that directory where I unzipped my tool. Okay, cool. So to use it here in Solaris, just type Lighter, and this is the tool. And once you get it there, you can see that it's kind of moving like crazy. I think that's on purpose. I don't think that's a bug. So you basically can't see what's going on. And that's pretty much it. Just connect it here, and that's what you get. So let's take a quick look, because as you can see, we get this fancy interface here. Okay, so we need to go through that and see what's going on in there. Hello, 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 1, 2, 3, 1, 2, 3. So as you can see, this tool is basically an HDA. So if you dive inside, well, here you can see a bunch of things. I mean, you don't really need to dive inside ever, but if you are curious and you want to know how it works, you can just go inside and take a look here. But basically, it's doing some sub stuff here, and this is mostly for the geometry creation that we're going to see in a minute. And same with this copper network, where same thing, it does a bunch of things that, this is basically what's happening under the hood, but you don't need to go here ever. Okay. So as you can see, this comes with an HDRI. This is a sample HDRI. So, well, the first thing you have to do is get rid of this and use whatever HDRI you need to use for your shot. This, I don't know if this is a bug or not. I guess I need to ask the person that built this tool. But as you can see, the first thing you have is a prim path, right? As everything in USD, you need to specify a primitive path. If you go to my scene that I have here, I already defined a prim path where I want to place all my lights. But what I found is if I specified my custom prim path here, the tool doesn't work or it crashes. Not all the time, but when extracting the practical lights. So I'm not going to use my print path here. Okay, so this is basically going to create a new print path, which is shot lights lighter 1. We can stick to that. Again, if this is a bug, I guess it has an easy fix. Otherwise, it's not a really big issue because we can change it later. Okay, we can change it later because at some point we're going to stop using this tool because we're going to create like Solaris primitive for all the lights that we're going to extract. So at this point, it's not really a big issue. It would be nice to do it here, and it will be fixed later automatically, but we just need to change it later. It's not a big deal. Okay, so then we have this input HDR map. This is the map that you want to use. So just go here and select the map that you want to use. In my case, is this Studio Small HDR image. So let's get that one there. And at some point, this will update and it will show our HDRI. There you go. Okay. So as you can see here, well, this is still doing something. Okay. As you can see here, it has detected automatically 1, 2, 3, 4 images. But this one and that one, this is the same light, but because they are on the edges, it might be a little bit problematic. So I'm just going to offset the HDRI. And you can do that here in highlights detection. Here you have this rotate map option. So I'm just going to rotate this a little bit. So I'm just going to say 90. And again, these are just transformations, so we can counter this transformation later if this is exactly the original orientation that we want to use. But basically, I'm going to type here 90, and as you can see, this will offset. You can see that it's cooking down there. This node is not super fast. So something that is important is once you are happy with the results, we need to cache everything out and get rid of this node. Okay, because every time you do something, it's going to cook. Okay, done. So it's done. So now you can see up here that my lights are very well covered now. Okay, that's great. Then probably the first thing that you notice is that these bake all textures or this bake environment light texture now is red. That means that we haven't baked these results. And actually, let me do one thing here. I'm going to need to make a little bit of room here. I'm going to add some Karma render settings. I'm going to connect that one there. And I'm going to take my render camera here. Okay. And let me do something here. I'm just going to go to camera effects and get rid of depth of field and motion blur. We don't want any of that. Okay, cool. So if we render now, it takes a little bit to cache the textures, but we should see it in a second. As you can see, this is not right. This is some kind of red color that is tinting the scene. That is because we haven't cached those textures. So again, this is red. So that already indicates that something is wrong. But if you try to render, you will get something red. By the way, let me change this one to dark. And I'm going to get rid of my grid. All right. So far, we haven't done much. The only thing we've done is changing the orientation of the HDRI by offsetting in Y. And this is something that traditionally we would do in Nuke with a spherical transformation node. We do this all the time to change the orientation. This would be the same as getting a dome light and rotating this one here, right? So by doing that, we change the orientation of the HDRI. Okay, great. Then this output HDR map This is where the new environment map, or once we create individual practical lights, we're going to be creating maps for those also. So this is basically where all of those are going to be saved. The next option here, output HDR resolution, same as input. So that's great. This is going to create a new map based on the same resolution as the original map that we're fitting here. And this light bake resolution, this would be, and you need to be very careful. As you can see, I just selected this and it's cooking the node. So you need to be very careful with selecting things and all of that because it's very sensitive. I think that can be changed. Hopefully, that will be changed in the future. But here you can change the light bake resolution for the individual lights. So as you can see, you can go all the way up to 512 by 512. I would like to see an option here to bake this at higher resolution, because depending on the type of lighting source that you are baking, you might want higher resolutions. Maybe not for lights, for practical lights, but if you have something like a window and that window is quite big, imagine that you're in a cathedral or something like that, and you have those huge windows, you might want greater resolutions for that, because that's going to be visible in the reflections and whatnot. So hopefully we can have a high resolution option here. If that doesn't get added by the author of this tool, I mean, this is just a cop operation inside, so you can just dive inside of the HDA and change that yourself. And then we have this light bake blur, and that will blur the image. This is cop, so it's a little bit expensive, but you can do it. Well, that will sometimes help you to reduce artifacts and potentially fireflies and other things, but it's not something that I usually use. Okay, so those are the main options. Then here, and these options are something that I don't usually mess with, but again, I guess it depends on the HDRI that you're using. So this is the detect map resolution. So basically, the higher resolutions that you use, it will divide the light in multiple sections. In this case, it's not going to do much, because this is basically, these are soft boxes, so it's pretty well defined. But if you have something like a window, actually, if we create another lighter, we can test the. We can check this with the test or the sample thing that we have here. Okay, stop shaking. There you go. So let's see if we can make this a little bit bigger. So if we take this detect map resolution with this size, as you can see, it's selecting the whole window, right? But if we go higher resolution, it's going to probably divide each of these into multiple lights. So let's give it a go. It doesn't seem to do it, right? Maybe it's a combination of playing with that one and, I mean, it's doing something. There you go. Yeah. So as you can see, well, when I change a little bit, these clip lights also help to do that. But yeah, as you can see now, it's creating multiple lights based on, different features, because this is a Windows, of course, is richer than just a softbox, because this Windows has, probably on the top, we can see the sky and maybe some buildings here. Maybe it's covered with some buildings, so we have less dynamic range or less brightness, let's say, and same on the bottom. So this basically will split your lighting source into multiple CG lights. So again, if you want to use that, fine. In my case, I don't really need to use it, right? Because here, Let's select that light. I'm using softboxes, so there is not much detail there to split the lighting source into multiple practical lights. Okay, so it's doing a great job, as you can see here. And then you have these options to help you refine the selection. Like clip lights, basically it will reduce the clipping value. So basically, if you have a window, again, because there is so much detail there coming from the outside, if you reduce the clipping, it will pick more details from the different values that you can find in there. Here again, it's a softbox, so it's pretty flat in that sense. So there is not much to play with. Same with blur. Same with dilate and erode. So basically, this will expand or contract the selection. And then you have this threshold, which is by default set to 0.5. So imagine that you have windows, and in those windows you have window frames, right? So if you don't want the window frames to be part of the light, you probably need to increase this threshold. So those window frames are not part of the image, part of the practical light, because the difference between the light and the dark values of the window frames and whatever is outside of those window frames is too big. That's basically how you use these things. You can play with them. Generally speaking, I don't think you will have to play a lot with those. Let me get rid of this lighter because I don't want it to cook. As you can see, even if you select it, it starts cooking. So you don't want these guys living in your script. Okay, cool. Let's go back to ours. There you go. Cool. Right. Then we have the rotation options, and I've used this already. Basically, it's a spherical transformation in all axes. Generally speaking, the only one you will be playing with is rotation in Y. But again, you can do this beforehand if you wanted in Nuke, or this is up to you. I usually tend to do this thing that I done here with my HDRs. I always try to place the sun in the middle, or if there are multiple lighting sources, like in this case, I usually try to have them all together, right? I don't want to split a light in the middle by having them very close to the edges or whatever. But that's just a personal preference. Okay, then we have this master intensity, and that would be the master intensity of everything that you can see in this map. I don't change this here ever. I change that later when I'm calibrating my library, once I have all of these split into multiple lighting sources. Okay, so with these settings, it has detected 4 practical lights, 1, 2, 3, 4. That is all good. That's basically what we have. And now, as you can see, it has created tabs for all those lighting sources. The first one being the environment light. So this is the environment light. And something that is pretty cool is like it has the most common parameters here, like enable or disable, color tint, exposure, and then it also has options for name of the light and name of the light path expression. That is great. Let's make this a little bit bigger. And same for all the other lights. So we have light 1, light 2, light 3, and light 4. So here we could change whatever we want. So let's say that light 1, we want to tint it. So let's say we want to tint this light like 0 and 0, and maybe expose it a lot. So if we do this, now we can bake all this information, and it's going to bake it into a new HDRI. So let's do that. Bake all textures. And as you can see, this is cooking. And at some point, we're going to get a pop-up. There you go. So basically, as you can see, this is rendering a copy network. Okay, it has been rendered, and as you can see, these bake all textures. Now this is green, meaning that it has baked everything properly. Let's go back to COPS and let's take a look at, well, we have this activated, so it's basically rendering this again, my bad. Okay, but you can see there that it's doing that. But what I wanted to do was actually to come here to this copy network and take a look at the thing. So this is the original image that we use, right? But if I take a look now at scripts, text, lighter, and here I have this environment light. There you go. Oh no, sorry. This is something that I had from before. My bad. I didn't want you to. I didn't want to show you that. Okay, never mind. Let me go back to Solaris. And I just want to get rid of everything that I have baked from before. There you go. Bake all textures. I'm going to bake everything again. Okay, it's baked now. So let me go back to my COP network. Reload. There you go. And now, as you can see, we have a new orientation and we have this light tinted red and where we have increased the exposure, right? Okay, cool. So let's go back to Solaris. So basically we have created a new HDRI with those tweaks that we made here with this tool. Okay, so if we render this now, it will take a couple of seconds to cache everything. There you go. But now it's rendering fine. And well, that red that we're getting is now coming from the light that we tweaked. I just wanted to make this quite evident. But as you can see, this is working. But so far, the only thing we've done is modifying the HDRI. Basically, just the image that I showed you in COPS, right? This is working fine, but we haven't extracted any lighting sources, any practical lighting sources yet. This is just in case that you want to modify the original HDRI, but you are modifying individually the lighting sources, but we haven't extracted these lighting sources yet. Okay, so I'm going to go back here. And I just want to set all of this to 1 and this one to 0. So basically, it's using the original information from the HDRI. So the only thing we've done now, the only thing that we altered in this HDRI is the orientation, but the rest is exactly the same. So I'm going to bake all these textures again. So I just want to make sure that I'm basically not modifying anything that I don't want, and the only thing that I want to modify is the orientation of the HDRI. Okay, so just make sure that things are working. So I'm going to jump into Karma, and as you can see, it's not really working, and that's probably because it's cached into the memory. So I'm just going to click on Restart Render, and that should clear the caching. Okay, yeah, so now it's working. So now we get the original HDRI, but with the right orientation. So this is cool, this is great, but again, now is when the artistic control or the technical control comes into place. If we want to change any of these lights individually, or if we want to add or change settings individually, or add more sampling here or less sampling there, or tint this light or whatever we want to do to this HDRI, now is when it comes very handy to split this HDRI in multiple lighting sources. So I'm going to go back to Houdini OpenGL. And now that everything is cached, we can basically select this lighter again. And as you can see, if we select any of these lights, we can select them. And as you can see, it's changing this tab here. So it's basically going from one to the other. We have different options here. We can right click on a light and click on separate or unfill. So you can see here, separate and unfill. And we can do the same in these tabs here. So for example, with light 1, I'm going to click on separate, meaning that I want to separate that light. Click. And as you can see, it has created a CG light that represents that light. And once you've done that, you also have a renderable option. So you can see it in the render as a physical light. And you also have this fill background, which is going to get rid of that light in the environment HDRI and fill it with adjacent pixels, basically. So we're going to end up with an HDRI, environment HDRI that doesn't have this image, and then a CG light that has that image. So, okay, we've done that. We can tint it, we can change the exposure. We don't want to do that. The only thing that I want to do here is change the light path expression name to the same name as the light. There you go. Then you can change the type to be a rectangle or to be a disc or to be a point. You can change to whatever type of lighting. Generally speaking, it's going to be rectangles because we want to map an HDRI. Well, rectangles or discs. And then we have this use texture to map the textures. Otherwise, it's just going to use a value. And then we have this distance, which is an arbitrary distance, really. I mean, this is not spatial lighting. You know that I like to talk about spatial lighting, spatial HDR lighting. That's a more advanced technique. This is not what we're doing here. But, you know, this is an approximation. So let's set this one to, I don't know, let's say 5. Okay. So now this is over there. Great. So we have the first light. I'm going to take the second light and I'm going to do the same. Separate it, fill background, and renderable. And I'm going to change the light path expression name to be, this would be light 2. Use texture, and I'm going to use the same distance, 5. So if I type 5 there you go. So now we have the other image over there. Okay. And as you can see, this is matching very well the orientation and, well, the distance. Again, this is an arbitrary value, so you would have to tweak that. Let's go to the third one and do the same. I'm going to change the light path expression to light 3. Use texture and use a distance of 5 also. There you go. And we're just missing one light. So let's do the same. Separate, fill background, renderable, light path expression name to light 4. I'm going to use texture and use the same distance, 5. There you go. So they are probably a little bit farther away than they should be, right? I don't know. I mean, this is, again, we would have to test all of this. So I'm going to go to 3, 3, 3, 3. Okay, yeah, this looks pretty good to me. Great. And again, now you can change, if you wanted to, the tinting or the exposure or any of the settings. I don't like to do that. I just want to extract all the information, and I will change all of that later in my HDRI rig, because it's faster, basically. Okay, and maybe the environment light, I'm going to change the light path expression to be the same name, environment light. There you go. So we need to bake all these textures, right? Because remember, what we're doing here is removing all the light sources from the HDRI. So we're just going to keep the environment lighting, the omnidirectional lighting. And then we're going to extract those textures and map them into these CG textures, CG lights, sorry. Okay, cool. So I'm going to click on Bake All. And this is going to bake 1, 2, 3, 4, 5 different textures. The 4 practical lights and the environment light. Okay, this is done. So let's take a look at the textures first. So again, I'm going to go to Composite View. Let me go to my copper network. And here, as you can see, we have 5 textures. So the first one, if we reload that, there you go. So, you know, I mean, the patching work could be better, sure. But, you know, this has all been done automatically for you. If you want to do a better job, this is a really good starting point. So you can just take this into Nuke and do the cleanup yourself, okay? And then if we take a look at the other textures, so there you go. This is the texture for the first image. And again, these are HDR textures. So we have all the dynamic range here. Then we have the second light, and then we have the third and the 4th light. Okay, that's great. Let's go back to our image. Let's go back to stage. And let's restart render. Well, let's go to Karma, restart render in case there is something in the cache. Okay, so this is rendering. I'm going to do one thing. I'm going to hide these icons, and I'm going to get rid of my environment light as background. And this is working. Maybe, you know, we don't want to see this light here. So, you know, we can basically get rid of renderable, but we can change that later also. So yeah, I mean, all of that is good. The only thing though, I think the distances are too close, right? I think this is too close. So basically I'm gonna go back to my original plan, which was 5. Okay. Okay, that's great. We don't need to bake anything, right? Because we haven't changed anything to the textures. So this is working. Again, let's go back here. Let's render this guy. And this is working. Okay, that's all good. Let me save this scene, by the way. So, well, this light rig is not done yet in terms of calibration. It's not maybe done. We need to tweak that. But I'm not doing this with this lighter node anymore. Again, because it's slow, it's a little bit buggy, it can crash sometimes. So basically, now I want to extract all this information, and because we haven't changed anything at all in terms of intensity or white balance or exposure or whatever, the only thing we've done is extracting the information. Now we can play with it as, you know, any other light rig. Okay, so let's do that. So let me go back to Houdini EGL. Okay, and there are a couple of ways of doing that, but the most automatic way is just selecting the lighter and click on Extract Lights. Click there, boom, and this will create all of this for you. So what this is doing, it has created all this. So we can ignore this guy because we don't want to cook that because it's very slow. So let's put it there. Let's take our camera render settings down there and let's organize this a little bit better. So do that and put it here. So we have a layer break, great, and then we have this thing. So the first thing it does is creating a primitive that is setting the prim path for the lights. And again, this is what I told you before at the very beginning, that it didn't work when we changed it, but it doesn't matter because now we can well, it's cooking. Don't cook. Because now we can change it here. So this is creating something called shot, blah, 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 blah. I don't want to do that. So let me ignore that guy. Then it adds a transformation here in case you want to change everything in terms of transformation of your light rig. So basically, we could rotate this guy and all the HDRI, you can see it here. I mean, the HDRI and the practical lights will change. So from shot to shot, you could reuse this for orientating, for the orientation of your lighting. Okay, so we don't need this to here, but we want to fix this now, right? Because this is placing this in the wrong context. So let me just copy this. And now we can just paste that here. There you go. So now our light is going into the right place. I'm going to do the same for all the lights. There you go. So now all my lights live in the context that I created when I was designing the shot. Okay, that's great. Okay, great. Camera render settings. Let's go to our camera and render this. Let me hide these icons that I hate. There you go. So now we are, let me go to native viewport camera. Okay, so now we have exactly the same lighting that we had originally because we haven't changed anything, but now we can change everything individually. So we can change the environment light or we can change any of the practical lights. So of course we can just use a light mixer here. There you go. And now in this light mixer, we can just take everything, move it over there. Great. So now we can just go to light 1 and change the exposure to something like 2. There you go. And as you can see now, we're affecting only to that light. Let's tint it a little bit. So let's give it like a, there you go, some kind of, let's pretend someone is watching TV down there. So I don't know, yeah. Something like that. This light 2, which one is this? I mean, I don't know. So let's give it a crazy value, 5. Okay, so that is a front light. So let's keep that one to something like that. So now is where we can start making those creative decisions that we couldn't do before, right? Okay. There you go. What about this one? Which one is this? Okay, so that's another rim light. So let's set that one to maybe something like 1. There you go. So now we get this nice rim over there. And finally this one, which one is this? Okay, this is some kind of kicker, I think. There you go. Okay, so I'm gonna keep that one to the default value, and then we have the environment as well, right? So if we set this one to 1, there you go. Now we're affecting the whole image. So as you can see, we have way more creative control now. Not only we have more creative control, but we also have, you know, all of this individually set here. So we can just select an image, and if this, if we're getting noise from this image, we can basically go to Karma and we can control the sampling of this image, of this light individually instead of the whole HDRI. Okay, so that's very important. Let me go to my Karma render settings. I'm going to go to my image output and I'm going to split per light path expression tag. And because we exported the light path expression tags from this tool, that should be set, right? So if I select this light and I go to, there you go, light path expression. This one is called light 1, light 2, I would hope, and so on. Yeah. So if I check my AUVs now, yeah, this is my environment light. Okay. So this is the contribution of my environment light. This is the contribution of my light 1, light 2, light 3, and light 4. There you go. So now it's very easy to tweak this light rig because I have access to my light path expressions. So maybe I'm going to go to this one and give it a little bit of boost. Just a small kick over there. Let's see what it does to the global image. Okay. Yeah, that's cool. Maybe we can do something with this one. This is a bit more evident. I mean, this is now a little bit overexposed, right? So maybe let's set the environment back to 0. There you go. And this gets a little bit more rich when it comes to shape. Okay. Maybe you want to do something a bit more warm over here. So there is a fire off camera, whatever. Okay. So yeah, this is basically how you use this tool. And finally, we've done our layer break here. So now we can just go here and do our USD ROP. And just write this as USD layer, which I can do here, lighting, version 2, save to disk. Great. So now we can go here, or basically we can go to our sublayer that we had originally, which is this. Get our new lighting layer. Okay, and connect this one to our render settings. And if we render this, this is basically what we get. Of course, we didn't have the background when we started lighting these shots, so these lights obviously they need to move further away. So 5 units wasn't enough. But we didn't have that backdrop, so of course we couldn't know. But anyway, this is basically what you get now. Okay, you can also do this here. So now we don't need to worry about that backdrop anymore. Okay, well, this is basically it. I just wanted to show you this tool because, again, this is something that we do all the time in visual effects, and we usually go through Nuke to do this, or in-house tools that we have in some of the facilities. So I think it's great having this tool. As you can see, it works. It's a little bit buggy sometimes. It's a bit slow sometimes, but generally speaking, I think it works very well. And you can save a lot of time by using this tool. So thank you very much to the person that created this tool. Don't remember his name. I'm sorry about that. I'm pretty sure it's somewhere here. Oh, there you go. Anton Grabovskiy. I probably said that terribly badly. Thank you very much for providing this tool. Again, if you want to use it, please say thanks to Anton, because this is a tool that is production oriented. So he definitely knows the value of having something like this. So please send thanks to Anton. And if you liked this video, well, check some of the other videos that I have on YouTube and Patreon. And I'll see you later. Bye.